Alright, so now that we know what complex numbers are, let's see how we use them and work in the complex realm. So complex numbers are made up of real and imaginary numbers, and you'll generally see them in this form, a plus bi. And we saw this when we worked with the quadratic formula, and when we got to our answers with i's in them, it came out to a number that looked like this. So the a is your real number, and then the imaginary is the number with the b and the I attached to it. So it's important that you're able to identify what's the real part and what's the imaginary part of your numbers. So for every number, you can identify the two pieces. So in this problem, 5 is your real part, and 2i is your imaginary part. -3 is the real part, and 2i again is the imaginary part. Here, there is no real part, so we would say 0, because adding 0 won't change anything. And your imaginary part is 4i. Here, there is no imaginary part, just a real part, so you would say 0i. And then finally, the real is 2, and then -i. So with imaginary numbers or complex numbers, you can also perform operations with them. So this includes adding and subtracting, and then multiplying and dividing. So, sorry, let me just adjust the screen. Let's look back at how we add and subtract real numbers with variables. So when we work in the real numbers, we just combine the terms that have the like variables and the same exponents. So if I have 1x and I add 2x's, altogether I get 3x's. Here, I have 1x squared plus 3x squared and then plus an x. You can only add the ones with the like exponents and the like terms, so I have 4x squareds and then 1x. Here I have -3x minus 4y plus 5x, so I can combine the x's together and the y is by itself. So -3x plus 5x is positive 2x, and then minus 4y. And then for the last one here, there's actually no terms that can be combined because they don't have the same exponent, so I'll just rewrite it in order of exponent, which we'll start working on next unit when we do with polynomials. Alright, so let's look at the imaginary numbers. So the same rules apply. You're adding the terms that are similar. You combine the real numbers together, and then you combine the imaginary numbers together. If it helps, think of the i's as like x's when you're combining like terms. So here we're adding this imaginary number with this imaginary number. So I'm going to combine the 5 and the 4 and get 9. And then 3 plus 2i is 5i. So you can perform operations with them. It's the same steps that you would do in the real numbers. So this is nothing new. So let's try some practice problems here, and you can pause the video if you want and try these, and then start it again to see what the answers are. So here I'm going to take -1 and add it to 2. So that's +1. And then 2i plus another i is 3i. Again, take your real numbers. 4 plus -2 is 2. -3i plus -5i is -8i. Here I'm subtracting, so I just have to remember to subtract the term when I'm going from one set of parentheses to the next. So I have -3 minus 4. -3 minus 4 is -7. I minus I, the i's cancel, so there's no I term left over. Here I have 5 minus 5. 5 take away 5 is 0, so that goes away. -2i minus -7i. I'm going to write that out. -2i minus -7i. Remember, two negatives, when you subtract them, they become a positive, so it's really -2i plus 7i, so this turns out to be 5i's. So for adding and subtracting imaginary numbers, the same rules apply. You're just combining the like terms, and this time we're looking at the real terms with other real terms and imaginary with imaginary. Let's take a look at some powers of I and multiplying with I. So let's remember that I itself is the square root of -1. So if I wanted to know what I squared was, I know I is the square root of -1, so I'm going to square it. What happens to our radical when we square it? Well, remember, this is the inverse operation. It undoes this. So I squared really turns out to be -1. If you do I to the third, we know that I can rewrite I squared, or I to the third, as I times I squared. Because when you multiply, you add the exponents. So this is 1I, and then I squared would give me I to the third. So I know that I is just I squared is -1. We just talked about that. So really this turns into -I. The last part, I to the fourth, I can rewrite I to the fourth as I squared times I squared, because 2 plus 2 is 4. So I know that I squared is -1 times another I squared, which is -1. That actually turns into +1. So there are some special relationships with the powers of I. Really the most important one that you should know is that when you square I, it becomes -1. So I squared equals -1. That's going to impact us when we're working with multiplication. So let's look at multiplying with complex numbers. When we did it with the real numbers, you just distributed. So you had to make sure you multiplied by both terms. So -2 times x is -2x, -2 times 3 is -6, and you were done. Here, when I multiplied a variable times a variable, x times x gave me x squared, x times -5 is -5x. Again, multiplying by a variable, -x times 2 is -2x, -x times -x is +x squared. And remember, the official correct answer at the end is when you write your answer in order from highest exponent to smallest exponent. So this is actually your final answer. And then finally, the last problem, just distribute that x squared plus 1x. So we're used to doing this in the real numbers. Now we're going to apply it to the imaginary numbers. And the same rules apply with distribution. You have to distribute the term to both the things inside the parentheses. What's different now is when you see an I squared, you can automatically turn that into -1. That is the only thing that's different about multiplying with imaginary numbers. So if I'm going to distribute I to both of these things inside the parentheses, this turns into 3I plus I squared. Well, now I know that I can rewrite I squared as -1. So really this turns into 3I minus 1. And to be exact, we write our real number first, and then you add the imaginary part after. So that's your official final answer for I times 3 plus I in parentheses. So the new thing here is when you multiply I times I, you get I squared, and we know now that I squared is -1. So if I distribute in each of these problems, you can pause the video and try these on your own, or continue with me. Come back and check though. So I times I is I squared. I times -5 is -5I. I know I squared is -1, and then minus 5I. This is my official answer because it's in the form A plus BI. So when you're taking an ACT or a standardized test, your multiple choice questions will probably have the answers listed in the standard form. Here I can distribute 3, so I'm just multiplying 3 times 2 is 6, and 3 times I is 3I. And you're done. There's nothing else to do there. There's no I squared, so we're not having to do anything with that. Distributing -I times 1 is -1I, and I times I is I squared. I know that I squared turns into -1 though, so I'm just rewriting it, just the value that it equals. And then now I have to put it in the standard form, so I rearrange the terms. Last one, distribute. I get 4I minus I squared. So it's 4I minus -1. Notice I have to put it inside of the parentheses because of the minus, because now it changes it to a +1. And then to rewrite it, it becomes 1 plus 4I. So remember, your final answer always should be in this form of a real number plus the imaginary number. So let's try working with operations of complex numbers. So I have two sets of problems for you to work on with adding and subtracting and then multiplying.